Hello students, I welcome you all to this class. This class we'll be studying this topic integration by parts. We started the study of integration by parts in our previous two classes. So this we'll be solving this third example on this topic, and we are going to make use of this formula I gave you in our previous classes, that integral of u dv is equal to uv minus integral of v du. So this is the formula I gave you in our previous classes. So, and we say that both u and dv are functions. So you are integrating product of two functions. We have this example to integrate. We are also to evaluate integral of x exponential minus x dx. So we have x and exponential minus x. Which one do you call u? Which one do we call dv? So the one you call u is the one that will vanish if you differentiate it a certain number of times. So if you differentiate x, you get 1. If you differentiate 1, you are going to get what? 0, because 1 is a constant. So the derivative of x will vanish at a certain number of times of derivative. But exponential minus x, no matter how many times you differentiate exponential minus x, it cannot vanish. So because of that, we are going to call u x, that's the one that will vanish, you call it u, and you call the other one dv, you call dv exponential minus x. We also saw that the one you call dv is the one you are going to integrate, and the one you call u is the one you are going to differentiate. So I'm going to say let u be equal to x, and this implies I will differentiate this u with respect to x, because the one you call u is the one you differentiate. So du dx, if you differentiate x, you get 1. And this simply implies that, because in our formula we have du in our formula, so we need to make du the subject of the formula, so that du will be equal to dx multiplied by 1, which will give you dx. We also, since we call u x, and the second function automatically becomes our what? Dv. So I'm going to say let dv be equal to exponential minus x. The one you call dv is the one you integrate, because if you integrate both sides, you can get v, which we are seeing in our formula. So that integral of dv will be equal to integral of exponential minus x with respect to x. But integral of derivative, integral will cancel the derivative, so leaving your v. And if you integrate exponential minus x, plus minus exponential minus x, so you can now go ahead and apply the formula, so that integral of x exponential minus x with respect to x will be equal to, so remember we have uv, right? Uv, our u is x, we call u x. We calculated v to be what? Minus exponential minus x. So if you multiply both of them, you are going to have minus x exponential minus x, then minus integral of v du. What is our v? Our v is minus exponential minus x, minus exponential minus x. What is our du? We calculated du to be equal to what? Dx. Dx. So we are going to continue the solving. This is equal to minus x exponential minus x minus, we are going to have minus exponential minus x divided by, remember I told you that if you want to integrate exponential function, you differentiate the exponent and bring the result down. So if I differentiate minus x, I'm going to get what? If I differentiate minus x with respect to x, I'm going to get minus 1. So I'll bring minus 1 down here. And what is up will be what? The exponential function you are integrating, minus exponential minus x. Then we are going to put the constant of integration c, so that if you simplify this further, this will minus x exponential minus x minus, that's this minus here. And this minus will cancel, remaining exponential minus x, then plus what? C. So with this, we have gotten the result of the integral of the product of these two varied functions. So I'm expecting you in our upcoming class as we treat more examples on this topic. Bye.